Welcome to the session. Today we are going to discuss about what other forces are acting on this very part of an engine. First, piston effort. It is the net force acting on the piston or grasping head along the line of stroke. It is denoted by Fp. When fuel is burned inside the engine, above the piston head, above the piston, between the piston head and the piston, the fuel is burned. So what will happen due to the burning of the fuel? Some pressure will be take place. Due to the pressure, what will happen? The force, the pressure will tend to move the pressure piston. That force is called as piston effort. What the force acting on the piston tends to move the pressure piston. That force is called as piston effort. It is indicated by Fp. Fp is equal to net load on the piston plus or minus inertia force. So depends upon the direction of movement of the piston, the net sign will be applied. Also, some frictional forces also considered. That friction force is in the opposite direction of the moving direction. So it will be indicated by minus sign. So Fl equal to net load on the piston plus or minus Fi, the inertia force, minus Rf, the frictional resistance. So the negative sign used for the piston is accelerated and the positive sign is used for when the piston is retarded. For the double acting reciprocating steam engine, net load on the piston becomes Fl is equal to P1A1 minus P2A2. Because of both the side direction, both the side of the piston, we have some pressure. But simulating engine having one side only, we have burned the fuel. So for the double acting reciprocating engine, P1A1 minus P2A2, that will be equal to P1A1 minus P2 into A1 minus small a. Because of the other side of the piston, back side of the piston, there is some space occupied by the piston rod. That's why we have to subtract the piston rod area. Then the other force acting on the reciprocating part is force acting along the connecting rod. In the direction of connecting rod, the force is Fq equal to Fp cos phi, because of the connecting rod angle with the horizontal is pi. So cos phi is equal to root of 1 minus sin square pi sin square theta divided by n square. We already derived that. So Fq become Fp divided by root of 1 minus sin square theta divided by n square. Then other force, the thrust on the side of the cylinder wall or normal reaction on the guide bus. That normal reaction Fn is equal to Fq sin phi. So Fq already we have derived Fp divided by cos phi. So into sin phi it becomes Fp tan phi. Then cranking effort. Cranking effort means Ft. So Ft equal to Fq sin theta plus phi. That will be equal to Fp cos phi. So
evaluation HOD mechanical department HOD
evaluation வந்துருக்கீங்க
அவங்க எவல்யூஷன்ல இருக்காங்க.
ஆமா
நான் 40